welcome to lecture number 17 of fuzzy sets, logic and systems and applications. So, in this lecture today we will be discussing the distance between two fuzzy sets. That means, if there are two fuzzy sets A and B, and then we learn to find the distance between these two fuzzy sets A and B. So, if we have two fuzzy sets, say A and B, means there are two fuzzy sets A and B within the universe of discourse X. So, the distance which is represented by D here, the distance D A comma B. So, here the distance between these two fuzzy sets can be defined by the extension principle, and this distance can be given by this formula here, and here we have two formulae, like one is for discrete fuzzy sets A and B. Let us say we have discrete fuzzy sets, then we use this formula to find the distance between two fuzzy sets A and B. So, as we all know that we represent the discrete fuzzy set by this representation. So, D of A comma B is equal to sigma over universe of discourse capital X, and then here we have mu D A comma B of delta by delta. I will tell you what the delta is. So, let us first understand here that this is the formula for finding the discrete fuzzy set A and B, the distance in between. So, here if we have, let us say, two continuous fuzzy sets A and B, like here in this case, where we will be having the distance between A and B fuzzy sets represented by D of A comma B, and this is equal to the integration symbol. This is integration over the universe of discourse, and then we have mu D A comma B of delta by delta. And since we are using here, so let me tell you first that we have the resultant, and this resultant in case of discrete fuzzy set we have the discrete fuzzy set as a result, means the distance will be a discrete fuzzy set. So, in a way we can say the distance is itself a fuzzy set. So, this distance between A and B, or in other words if I say the distance between two discrete fuzzy sets A and B is going to give us a fuzzy set which is again a discrete fuzzy set. And this is represented by summation over the universe of discourse, and then we have mu D A comma B of delta by delta. And similarly, in case of continuous fuzzy sets A and B, we have the resultant, the distance that we compute, we find is nothing but again a continuous fuzzy set, and this is represented by the fuzzy set which is described as the integration over the universe of discourse, and here we have mu D A comma B, and then we have of delta over delta. So, in these two expressions, one is for the discrete, another one is for continuous, both includes the mu d a comma b of delta. So, how to find this mu d a comma b of delta is here. So, if we see here, this expression is helping us in finding the mu d a comma b of delta, which is nothing but the max over delta is equal to d x a comma x b, and then this is for all the min values of mu a of x a comma mu b of x b. So, for every delta belonging to R plus. So, that means that this delta is going to give us some positive real value, of course, because we are computing the distance, and that is how this delta is coming out to be the real positive value. So, that is why this delta is coming from the set of positive real value. So, it is also mentioned here that the delta, because we already have seen that how we can find the mu d of a comma b of delta, which is needed when we are computing the distance between two fuzzy sets. Now, what is delta? So, delta is nothing but it is the difference between the corresponding generic variables of two fuzzy sets A and B that we have taken for a generic variable. And please note that we have x A and x B, and these are the generic variables of the fuzzy sets A and B respectively. So, we can say for every x A and x B, and these values for every x A, x B belonging to capital X, which is nothing but the universe of discourse. So, I hope this is all right to you, and with this we can manage to find the distance between any two fuzzy sets. So, now we know that we can compute the membership values of the corresponding generic variable values by this equation, by this relation, and delta, as I already mentioned, that this is nothing but the difference between the corresponding generic values of two fuzzy sets for a generic variable. So, let us now make this thing clear or more understandable by taking one example here, and this way we will be able to understand as to how we can find the distance between two fuzzy sets. So, here I am going to take two discrete fuzzy sets A and B. So, we have the first fuzzy set here as A, and then the second fuzzy set here is B. These two fuzzy sets are discrete, as we can see here, and we can represent it this fuzzy set like this. So, let us first take fuzzy set A here. So, A discrete fuzzy set is having three elements. So, first element we have here is the 1 comma 0.5. So, 1 comma 0.5 means we have 1 as the generic variable value, and 0.5 here is the corresponding membership value. Similarly, the second element here of the discrete fuzzy set A 2 comma 1. So, this 2 is a generic variable value and 1 is the corresponding membership value. The third element here is 3 comma 0.3. So, 3 comma 0.3 is nothing but we have 3 as the generic variable value and 0.3 as the its corresponding membership value. Now, let us draw this fuzzy set here, and this will look like this. So, we clearly see here that we have 3 elements in the discrete fuzzy set A, and when we draw this fuzzy set, we have at 1 as the generic variable value, we have 0.5 here, this is 0.5. So, 0.5 here is the corresponding membership value. So, it means that at 1 we have 0.5 membership value level. So, that is how we have drawn a line over here at the level 0.5. And then for the second element here, and second element has 2 as generic variable value, and for this we have its corresponding membership value as 1. So, that is how we have its level as 1. So, please note that this is a discrete fuzzy set, and for representing this we have taken a range plus minus 0.5 as the generic variable value. So, that is how at 1 we have at 1 here, we can see here at 1 here we have 0.5, and it goes this side and this side, both side 0.5 at the same level. This is just for the representation purpose, and this will help us in understanding this computation of distance between two fuzzy sets little better. So, this 0.5 plus minus 0.5 variation has been taken for all the points, all the elements of the discrete fuzzy set, and this way when we see here for the second element also, here we have its membership value 1, and you see here this side also 0.5 and this side also 0.5, it remains the same here. Similarly, for the third element of the fuzzy set, discrete fuzzy set A, we have the 0.3 here, the 0.3 as the membership value, and here also we have 0.5, plus side and minus side means left side and right side both. Or in other words, we can say the width of this column is 1, is taken as 1, and mean of this has been taken at the generic variable value. Similarly, this logic is applied to plot all the discrete fuzzy sets for distance computation purpose. So, here also if we see for fuzzy set B, here fuzzy set B, we have 3 elements again, and these 3 elements are, this is the first element and this is the second element and third element here. So, in the first element if we see, we have 2 comma 0.4, 2 is the generic variable value and its corresponding membership value is 0.4. So, we can clearly see here that we have at 2 we have 0.4 as the membership value. Similarly, the second element we have 3 and its corresponding membership value is 0.4. So, 3 here is the generic variable value, and 0.4 again means both 2 and 3 at the same level. So, 3 here will have 0.4 as its corresponding membership value. Similarly, the third element here is 4 comma 1. So, this 4 is the generic variable value and the corresponding membership value here is 1. So, we can see, and with the same logic that each bar, each column here is of width 1 and keeping its mean at the corresponding generic variable value. So, this means that we have this point as point 4.5 and this point will have 3.5. So, here also the same logic is applied. So, now we can clearly see that we have two fuzzy sets A and B and each fuzzy sets, I mean both the fuzzy sets A and B are discrete and these two fuzzy sets have 3 elements each. So, now our aim is to find the distance between these two fuzzy sets, these two discrete fuzzy sets. Let us see how we can manage to find the distance d of A comma B. So, for this as I have already explained how to find the mu of d A comma B means the membership values of the resulting discrete fuzzy set here and then the corresponding generic variable value which is nothing but delta. So, let us now go to the solution and for computing the fuzzy distance of the these two discrete fuzzy sets A and B. So, we first need to find the delta and let us see how we can manage to find the delta in each and every case. And as I mentioned here already that when we consider two fuzzy sets, let us say A and B, and both these are the discrete fuzzy sets, we represent the fuzzy set here A is equal to its generic variable value x A. So, x A is nothing but this is the generic variable values taken from the fuzzy set A, or in other words again we can say that x A are all those generic variable values which are present in fuzzy set A, and mu A of x A here is the corresponding membership values. So, similarly, if we apply the same logic, we represent here the fuzzy set B, and both these fuzzy sets are discrete fuzzy set which is very clearly visible. So, both these fuzzy sets are discrete fuzzy sets. So, let us now understand this also that the resulting fuzzy set here which is nothing but the distance d A B will have two components. One is the generic variable value, this is generic variable value which is here delta, and its corresponding membership value. So, we can say here this mu d A comma B of delta is a membership value, but if we have multiple values or if this is a general function, we can say is a membership function. So, now let us move ahead and find the distance between two discrete fuzzy sets A and B. So, as we have already seen that we have two fuzzy sets A and B like this. In A fuzzy set we have 3 elements, one is 1 comma 0.5, the second element we have 2 comma 1 and the third element here is 3 comma 0.3. Similarly, V discrete fuzzy set we have 3 elements, the first element 2 comma 0.4, the second element is 3 comma 0.4, the third element here is 4 comma 1. And as I mentioned, we can find here a delta by this expression, and delta is nothing but all possible differences in the generic variable values of the discrete fuzzy sets A and B. So, let us now first find out the delta set. Delta set is the set which has all the possible values of delta or r plus, means positive real value. So, since we have two fuzzy sets A and B, so let us take all the generic variable values from A and B both. So, for computing the delta. So, we see here that we have first generic variable here is 1 from A fuzzy set, and then the second fuzzy set B we have, and the generic variable value here is, we have generic variable value as 2. So, in a way what we are doing here is we are finding the difference in the corresponding generic variable values, and which are termed as the values of delta. Once again I would like to mention that all the delta values will be positive values, because we are going to compute the distance. So, let us first start from 0 as the difference. So, let us first find out what are the combinations of the generic variable values from A and B, which are going to give us the difference, the delta value 0. So, we see that here we have for 0 we have here, if we take 2 2 and 3 3 combination, 2 2 means this is from A and this is from B, this is from A, this is from B fuzzy set. So, and we have 2 here from A fuzzy set and 2 here from B fuzzy set. So, this is generic variable, this is my x A, I can write here as x 1, x A 1, and here I have x B 1, and this value is going to give us delta is equal to 0. So, we are interested here to first find the difference which is the least, and least difference is 0, because there cannot be any value of delta below 0, because we are interested in finding out the distance, and distance will be only a real positive value. So, the least difference is going to be delta is equal to 0. So, for delta is equal to 0, we can have two combinations. 2 2 means this is x 1 A and here we have x 1 B. Similarly, here we have x A is the second value, and here we have x to B. So, or we can otherwise we can represent these values, but here we are representing this way, that the first value, second value, and both these the pair of these values are from set A and set B, fuzzy set A, fuzzy set B. So, there are two pairs of the generic variable values 2 2 and 3 3. These two are going to give us, this is the first pair and this is the second pair. These two pairs are going to give us delta is equal to 0, and delta is nothing but the difference which is mentioned over here. So, this is mod of x a minus x b. So, these two pairs are going to give us delta is equal to 0, which is the least value of difference. So, when we start, the first and foremost step here is to start with finding the delta is equal to 0. In many cases, we may not have any such combinations for which we have delta is equal to 0. So, if we do not find any such combination, any such pair for which we get delta is equal to 0, we can simply move ahead for finding another or the incrementally the next least value of delta. For example, if we are not getting here any pair for which we are getting delta is equal to 0, we can immediately move ahead and try for getting delta is equal to 1. So, similarly, here also if we are not getting any pair, any such pair for which we have delta is equal to 1, then we can move ahead and we will try to find any such combinations for which we have delta is equal to 2. And this way we can keep on increasing our steps or moving forward to find the next least values. But if we get here any pair, like in this example we have 2 2 3 3. So, two pairs of the generic variable values and these two pairs are resulting delta is equal to 0. So, now let us see what we should do and how should we account this value. So, for delta is equal to 0, we have two pairs. So, that is how we are writing delta is equal to 0, you can see here. So, this is our delta is equal to 0. We write here, we have a table and this table will finally help us in getting the resultant distance of the two discrete fuzzy sets. So, we have the delta is equal to 0, we will write in delta column 0, and since we are getting two pairs, we will write those pairs here. So, since we have got two pairs, one pair is 2 2. So, we have written 2 here as x a and the 2 here also as x b. Why x a and why x b? Because this 2, the second column 2 is from discrete fuzzy set A, and this 2 which is in the third column is corresponding to the B fuzzy set. So, we have written here 2 2. Similarly, now we have another pair which is 3 3 for which we are getting 0. So, we will write here 3 3 as x a and x b, you can see here. So, let us now understand this as to how we are getting these values of x a, x b for which the delta is equal to 0. Now, another important point here is to list the corresponding membership values. So, the corresponding membership value here mu a x a. So, mu a x a we are getting here as 1 and mu b x b we are getting 0.4. So, which all these values are coming from the fuzzy sets, the discrete fuzzy sets that are given to us. So, we need not worry about anything, we need to just take the values from the given fuzzy sets and include in this table. So, we have 2 as the generic variable values from the first pair and then corresponding membership values. Now, what next? Next is that let us find the minimum of these 2 membership values. So, minimum of these 2 membership values means here. So, we need to find the minimum of membership values which is here. So, minimum of 1.0 and 0.4. So, we have 0.4. So, next is the second pair here 3, we have corresponding membership values as 0.3 and 0.4. We can clearly see here it is mentioned, is encircled here. So, we see here that we have 0.3, 0.4 are the membership values. Now, when we take the minimum of these 2 values, we are going to get what? We are going to get 0.3. So, these are the minimum of these 2, minimum. So, this is what we need to do. And then the next step here is for 0 as the delta. So, we need to find the maximum of these 2. So, here please understand that we have 2 pairs of the generic variable values from fuzzy set A and fuzzy set B, and these 2 pairs are for delta is equal to 0. So, when we have these 0.4 and 0.3, 0.4 and 0.3 as the min of these 2, we take the max of these 2 and we find 0.4. So, by now we have understood as to how we can compute the delta, and this way we can go ahead and we can compute delta is equal to 1, 2, 3 if these deltas exist. So, since the time is up and I will continue the rest of the discussion with respect to this example in the next class. Thank you very much.